If anybody's ever seen the docs, they just went through a major rewrite. We set up and changed to move everything to a Kustomize-based installation. So all of your references are now set up to use the newer deployment topology configuration. If we go to the install documentation setup install, you can get to this through the Spinnaker.io website. This will walk you through the new path. And what we need really is a Kubernetes environment. Uh, in this case, I'm going to be using microK8s. I've got a VM running with it available already to deploy to. You could use K3s, EKS, any number of other environments. Since I'm running locally, this is just what I tend to start with as a basic setup. A couple of repositories that I'm going to go ahead and link to. If you go to GitHub, Spinnaker, on the Spinnaker, we have a mono repo now where all of Spinnaker's install software code runs, including the installation we'll be using today, which is the Spinnaker Kustomize folder underneath it, which has also been updated to work with the latest releases. Now, I'm going to represent a couple of other things. We are going to look at packages. These are the Docker images that we will be installing in here. We are deploying on Spinnaker all of the Docker images to the GitHub packages repo at this point. I will be pushing the mean latest on these. So we'll hopefully haven't committed any bugs in the last, few hours, but we'll see how we go. Next repo, I'm going to link to and reference. I have a home lab where I run a lot of various things from Homebridge to Metal LB to various monitoring, Rook, etc. This is where I keep all of what I run, including things like, oh yeah, here's my GitHub config and various Spinnaker configs. Now I will note, I have not actually moved this off of an operator-based deploy to Kustomize, but I'm using this to sort of borrow configuration references, i.e. a git clone stuff. That said, the same things that I have there, we also have documented in here. So if you want to go through post config and find additional configuration, it should be pretty well documented. But for any issues, please join our Slack, ask questions, let me know if you hit issues. And I'll go through a couple of the different implementations and details as we go for, say, an example Git repo account. Those are the core links, repos that I will drop, and I'll put this whole workshop and links in here later. With that said, let's go ahead and it helps if I am in the right environment. There's my stop share button. Let me switch over to our command line where we will actually get this stuff started and running. So I'm going to bring up Ghosty over here. All right. So first thing I did, and I've already got sort of this set up, I've pulled down the Spinnaker repository. This should be current, just to double check. Yeah, there's a PNPM update, but nothing big. And the thing I'm going to borrow is this Spinnaker Kustomize. And I'm going to copy RPV, Spinnaker Kustomize out of the repo, so I don't need to keep it in here, and I can adjust as needed. Now, I have a simple server with a kube config, some credentials that I've got, which I'm obviously not going to share here. I have the Spinnaker repo that I said just clone down with the repo, but the real thing we're looking at is the Spinnaker Kustomize. Now, in here, we have the base components overlays. Base is the base installation of the various resources. And Spinnaker has a number of microservices involved that each do a different thing. Deck is the UI, Gate is the API front end where everything is routed through. Igor is your CI system. Roscoe does bakes for AMI baking. Each of the microservices does different things. Without getting into the weeds on what each of the component does, you do need most of the components for an installation. Now, the base has all of the various things like the deployment, the cluster role binding, service accounts, and even the base configuration files for a config. Most of the time when you're installing Spinnaker, these are the kind of base files that you wouldn't have to mess with a whole lot, but you'll note it already adds a managing account as a default entry in here. So it's good to know about these files, but do be aware that when we're modifying or maintaining an installation, a lot of times what we're going to be doing is in the overlays, which are things added on top of the base installation components. Now, components, we have two components, Redis and Maria. We do need both. Redis is sort of the cache, although there are certain things that are still stored in Redis independent of the cache system. Bake logs, for example, are stored in Redis. But the primary storage really is your MariaDB. In this case, MySQL, Maria both work. Postgres is a supported option. I think there's only a couple companies actually running on Postgres. Most of the time I say start with a MySQL compatible system. Now, the components in this case, we have files, customization. These components include init scripts for the various systems, as well as this components automatically configure Spinnaker for this installation. So components are your dependent services. The overlays are where you will do most of your configuration. And this has, for example, if we go into the files, we'll have a gate local, for example, that would have, and if we look at this, various things like API tokens. You will note here, this is documented of how you could turn on API tokens. Some default settings. Now, one I'm going to call out, and I've put it in the customize here. We run both the gate, which is the API layer, and the UI under the same ingress with a path-based prefix. So this makes it very simple. You don't have to deal with CORS issues. The one change is that it puts all API operations under, say, an API v1 prefix, and then it forwards those requests to it. And that changes gate to listen on that different endpoint. The other thing, and I call this out here, there's a default password. Please change this on any of your installations. This is an example of an installation. This isn't what you would use in production. Nominally, you would use, say, a SAML or an OAuth 2 provider for your authentication. But we want at least a basic username and password login that you can use. I'm going really fast. Please let me know if there are questions. The result of all of this, though, these files for each configuration, there's UI things like, hey, do we want to allow raw resources to be displayed? Do we want to allow Kustomize to work? There's all kinds of configuration options that are available. If you're an AWS shop, you don't want to show Google, so we can shut off a lot of those capabilities. In Kubernetes, you may want to show off raw resource visualization. In different platforms, you may want different visualizations. If you're doing RBAC and you actually want to do Okta and SAML, this is a configuration flag I recommend. Manage service accounts, because it makes permissions a lot easier. I'm not going to go through all the capabilities. As said, we have Slack where we can answer questions, the docs pages, etc. There's a lot of capabilities on the platform that can do a lot of different things. What we get into, though, is let's actually do the install. So we're just going to use our Kustomize build command, which will then generate the resulting manifests and deployment objects. Now, I'm going to go ahead and drop this into a Spinnaker here, and let me even do a namespace spin. Actually, I want to do it in the, I'm thinking different platforms. We're going to modify just so I don't have any kind of conflicts. Namespace, spin OSS, hey, or spin workshop. Let's do spin workshop. Now you'll note standard customization file. We have our resources, our ingress, the various components, the overlays, which then modify those base resources, as well as the images. We're pulling main latest by default. And in production environment, you would want to change that to a specific release. This is, though, what we are configuring at this point. So, all right, customize build. Again, very standard installation. Let's do spinnaker.yaml. All right, and let's take a look at what this generated. Vim, I have a Mac Vim, so I'm using that. So this will create our namespace, service accounts for each of the components, cluster role permissions, configs. So for example, you will note here the cloud driver and a cloud driver local. Both files get loaded. One quick caution, if you have files in a cloud driver YAML and a cloud driver local, these are Spring property files. Cloud driver local wins. So if you duplicate the Kubernetes block over to here, this one wins over this file. So be careful which and where you put things. The majority of the config I tend to put in the cloud driver local file or the various local files, as that's really things you're customizing. And a lot of the other files are supposed to be sort of more of your defaults. Now, again, get into various options. Cloud driver, you can see we've already configured SQL, cache, some defaults, various configs. These come from the component files and get auto-wired in for it. So I could spend a fair bit of time going through all the possible configurations. I think we've been shutting off some of these. We just removed worker, but there's a lot of things that can be enabled, disabled to control the behavior and the visibility of the platform. So this is all of the settings. One of the reasons we've moved to customize is to allow full control of the settings. Now, for my workshop here, I'm going to use a cluster environment that I already have. That's SN microcates, an example of something you might want to do in here. Let's see. Well, I just had a pop-up 2 seconds here. There we go. Back into it. Okay. So if we look volume mounts, a very simple example is it's a well, what is it? It's not volume template. It's volume claim templates. If you needed to change, say, the storage class. Now I'm putting it in here because I'm just modifying the resulting manifest. You would add this to your components or adjust, again, this files as you needed. But let's say I wanted to use NFS. And I would do it for both Maria and, say, Redis. And say, I'm going to use an NFS server instead of, whatever the case may be. You can tweak these for your environment as needed. And you will note down here in the ingress, I'm using a host of example.com. Obviously, you would want to change this to whatever hostname you would want to run. And here's where I mentioned deck is the UI, it's static JavaScript files. Gate is your API layer. You can add your certs. You can do additional things here as you need. I'm not going to get into how you configure ingress objects in Kubernetes. That's a different workshop for somebody else. But just be aware this by default will create an ingress that would handle a request to example.com. So let's see. I've got a kube config. I'm going to go ahead and apply this. Let's see this run. Are we ready? And let's hope I have enough capacity in this cluster. The total installation should be about 10 minutes, which unfortunately it's more of my cluster's capacity being an older environment. I occasionally hit resource limits. I'm running on a Proxmox environment on an old DL380. Live demos are always fun. Yep. Let me rerun just to make sure, but I'm betting it all ran. I've got an etcd versus, well, it's MicroK uses a DQ Lite versus etcd, and I've been having performance issues with that. Yes, unchanged, unchanged. I'm betting it all went through, and just the database lock is on one of the objects, probably. It'll go through. Oh, there it is, the service. And now, there's MariaDB. When you start installing this, oh, what was the name say? Spin Workshop. Couple things I'm going to note. You will note a lot of the pods go into a failure state, mostly because they are waiting on storage. So on a brand new system, MariaDB is not running. If he looks, it does some initialization stuff. It can take a little bit of time to come up. Hey, looks like it's starting. There's some init script files where it creates the various databases. Whenever it gets up in there, then services will start going healthy afterwards. So this does take, oh, I'm going to use the watch command, a few minutes here to fully run. Deck, as you can see, is already up. It's a static file. There's not much. MariaDB looks like it's healthy. We just got to wait for all the services and the dependencies to come up. So out of the box install, I didn't change anything other than the storage class. I've already got an Nginx ingress in this environment, although I'm looking at probably moving that to Trafic at some point as the default, given the Nginx deprecation situation. But out of the box, this should install and run and give you a clean install that will then route to a example.com. Now, since I need to have a ingress dash in spin workshop, you will note example.com on that address. I'm going to temporarily add that to my hosts file. Oh, I need to pop into an admin. Hosts. Always got to get approval. Okay, I'm editing my hosts file. And you can't see this, but I will drop it out in a minute. Okay, so if I cat my Etsy hosts, I created a very simple address that points to example.com. And you can see I can curl, and I just hit deck and got the endpoint. Now, none of this will load until all the other pods are up there, but I can actually start seeing some of the stuff running. And oh, there we go. Echo's running. Can't is not, but most of our services look like they're up and running. Orca, I'm going to delete the pod just to force restart it. So it comes up clean instead of waiting for the health checks to go through. Orca runs the pipelines. Front 50 stores the definitions for pipelines. So Orca is a very key service for this. While that's coming, I've got enough running that I should be able to log in and at least show some of the flow. And then I'll go ahead and switch my share over to the browser. And let's go to example.com and let's see how it works. Okay, there's our login. Remember, I did not change the password. Please change your password in prod. That was, let's see, I put in admin and Spinnaker says you should change your password. So admin. And hey, we're in Spinnaker. Now, if you've not seen Spinnaker, it does a lot. There's a lot to unpack just even in here. I will show you a couple of things. Pipeline templates. For templates, applications is the main view. We haven't created any applications. Let's go ahead and create a very simple app. This is our demo app, McKintosh at harness.io. And I'm going to say this is going to point to GitHub, home lab work, because I like to run there. Now, there's a couple of things when we look at Spinnaker. It's a CD platform. It's designed to continuously deploy software. When it deploys that software, it does a lot of operations for you. For example, checking health check to make sure that your deployed services work correctly. Depending on your environment, you may want to skip how it checks health checks. It looks at load balancer health state by default. But you can say, hey, don't look at load balancer, look at the node particular health check. And depending on your platform, if you're talking DCOS, you may not have a load balancer, so that doesn't apply to you. Just be aware there are certain configurations depending on what you're running that enable it. Now, permissions, I'm leaving off because locally I don't have permissions enabled with a basic username and password. There are other configs. Let's go ahead and see. I'm probably waiting on a couple of things right now to fully come online. Oh, I can't create an app unless Orca is running. Let me check and see if that's up and running. Nope, still not running. It's starting. It just takes a minute. Actually 5, because it has to initialize all of the database tables and does a liquid-based migration to build everything. Okay, let's see if that will come back now. Demo. Oh, GitHub. Oh, in this case, Jason McKintosh, home lab work. All right, let's see. Orca should be running. Great. I have my new demo application. Now, first thing I'm going to show you is tasks view. Anything you do from a pipeline operation to ad hoc operations goes through a task execution. For example, creating an application is just a task. You can see this view JSON. If we look at this, this will tell you exactly what it did. Hey, we ran a pipeline. It's a mini pipeline. It creates an application with this information. Hey, here's the different configuration for it. The task, upsert application task, which says save the application. It succeeded, was not triggered. So there was nothing really to execute there or track there. There's a lot of details on this JSON on exactly what a given system does. But these are essentially pipelines here. Tasks are called orchestration pipelines, but we also have regular pipelines. Now, a couple other things you will see out of the box. Clusters. You will note there's none found. You'll see a load balancer. You will see firewalls. This is one of the core things Spinnaker provided out of the box was sort of a cluster management, cloud management tooling. It will show you real-time state of deployed resources, i.e., Here's running clusters, load balancers, firewalls, and will refresh that information on a regular cycle basis. So it's not just deploying, it's also seeing the results of your applications afterwards. But let's talk deploys since we're talking deploys today. Now, deploying is fairly straightforward. Let's deploy an app. Pipeline name, pipeline. I'm not saving this as a strategy. Strategy is a conversation for another day. Like any other pipeline system, you have full control over the behavior of your deployment flow. Deployments are done through stages. So we can add a stage and we say, hey, let's deploy a manifest. Now, managing, if we remember, the default account that came in was added is the Spinnaker environment itself, meaning it will connect to the cluster where it runs on when you use that Kustomize. You can add additional accounts for other clusters, resources, or even the same cluster with different configurations. It will use kubectl for Kubernetes accounts under the hood for accessing those clusters. Now, override, you can override the namespace if there is an option, if the account has access to the namespace. You can see multiple namespaces in here and change the namespaces for your deployments. The next thing we get into is your manifest. You have different types, or text and artifact. Text you can manually copy in. So I'm going to borrow a very simple, because I mentioned my demo app. Let's take a very simple deployment app here. I'm going to copy it in. You can see here it's a standard Kubernetes manifest, apps v1, some annotations. This is a Spring Boot app. You can customize this however. I'm going to go ahead and add a tag. Now, in my case, I again am using GHCR. I have my demo web app here. Let's pull in 008. And I'll get into the continuous cycle where it can auto tag here later, but 0.8, I believe is how I tag that. Yep. So a very simple manifest. Now, rollout options. I'm going to call this out, and this came up actually in a Slack thread the other day. You can deploy a deployment object. There's nothing that prevents it. But if you want to control the behavior of that deployment, i.e. manage routing and number of pods and handle sort of your blue-green deployment, the Kubernetes deployment object does not give you a lot of control over the object and how it's rolled out. The deployment object defines how it's rolled out. This means Spinnaker can't really control the behavior of it. No platform can. So if you want to use rollout strategy with traffic, you can't use a deployment object. You have to use a replica set, which then lets Spinnaker control the behavior. So do keep in mind that gotcha here on this. And again, they even call it out here. You can only use replica set in this, and then Spinnaker will take over managing the traffic and the rollout of the traffic of it. I don't have anything here set up at the moment, so it won't be an issue, but just keep in mind that limitation on it. So namespace, I'm going to go ahead and say, we're going to say namespace here. That was our workshop, spin workshop. Now let's see how this works. Starting manual execution. I have no idea if this will work. I haven't actually tested this piece of it. Now, when we start, you will see, hey, it got the manifest because we hard-coded it. It has triggered a deploy. Now it is waiting for it. Oh, Cloud Driver right now does not have access to deployments in the namespace here. So I would need to adjust the permissions for the account that I'm deploying. Let's go ahead and tweak this. Since I can't deploy here, let's add a whole new cluster, and I'll show you how that works. I'm going to go back to my command line. All right, and you can see here, Roscoe's running, all the services are running, happy. Now, we're going to go into our overlays. I'm going to go in our Fig. We're going to go into Files. Now, Cloud Driver Local controls the majority of this. Now, remember, I'll show it back here in the base. There is in Cloud Driver a Cloud Driver YAML. I got to remember this. So you'll note here, it's got a primary account, various configs, live manifest, permissions, etc. It's only using the service account of where it runs with this. That said, I'm going to disable this because we're going to add a new Kubernetes account. All right, let's go back to our overlays. Particularly if you have different accounts between, say, a production and a staging environment, how you lay out your environment in here is entirely up to you. Typically, I will have a production and a sandbox environment. But let's go edit your Cloud Driver Local. All right, and here we go, Kubernetes. So our primary account, I'm going to call it simple. I'm going to create a new simple account. Now, when we set up some of this, there's a lot of different things, number of threads that it will use to load resources, so forth. One of the things I'm going to do here is a config file, which points to a kube config file. kubectl calls will be used. I'm going to do the first thing here. I'm going to use an encrypted file reference. I think I called it K3S. Let me find the docs for it real quick. Helps if I am in the right environment. 26.1. I added the ability on the latest releases to use an encrypted Kubernetes secret. I will hope I did everything wiring correct. As I said, we got a level live demo. Yeah, tell you what we're going to do in this case. We're going to do an opt Spinnaker config simple kube config dot reference instead. And the reason I'm going to do that here is just so you can see the full contents instead of doing all the encrypted file references and creating secrets for it. So we need a simple kube config mounted on here. Now, if we remember, vim opt Spinnaker config, we drop different files into an opt Spinnaker config folder. These are where all these config files that are running get put in. So if we look at a Cloud Driver local, and we're going to be moving this over here, you will see here's some of the files. So if we add to the files here, this, you get the Cloud Driver local contents on this. So we need a simple kube config added to that volume mount that we have in here. And that is in our config map in the config here. Again, I'm showing you all the details on this in here. And you can see, for example, Kustomize in here, container resources, everything that gets tweaked on these settings on this. For the moment, let's see, I need to add it to the base Cloud Driver. Again, I'm not going to do this how I would do it in production. Files, that's the wrong one. I want the Did we not create a... I don't think I've created a config yet on this one. Yeah, it's using the cloud driver YAML. Let's do a simple kube config here. Base cloud driver. I would normally do this in the overlays. I said live demo, right? Yeah, we'll do it here. All right, so files. I'm going to do a simple kube config contents. Now I've got a demo server on my lab. Let me pull the config there. Oh, over here. Microcades config. I'm pulling a local VM that I've got a hard-coded file on. This is a VM I spun up just this morning for this demo. Again, microcades cluster, it's on my lab. This will go away as soon as I get done with this. But I'm using, and again, I'm not going through all the details on it. This is a very, very simple cert-based auth on, or I think this one, yeah, this one's using cert-based auth. Your auth, your kube config is out of scope for this demo. Just be aware that each one of these is unique for whatever cluster you are connecting to. But it does fork out to kubectl, so whatever kubectl supports, you should work with. The cloud driver image where this will run has various CLI tools to help with some of that auth config. All right, let's see if I didn't typo anything. Kustomize build. And simple kube config. Okay, there's our simple kube config file now. You can see this is added in the cloud driver local. This should get mounted, if I did everything right, into that folder that gets put in there. All right. Now, the only thing I didn't save, and I should have done this instead of modifying that Spinnaker YAML, was my storage class. So let me add that back manually. So I don't break myself in the middle of this. All right, let's apply this. And okay, get pod / in. Did I type that? Yeah. All right. Okay, apply. Spinnaker YAML. So we've added a new account, the kubeconfig file for it, and now we're reconfiguring Cloud Driver to pick up the change. Majority of the stuff is on there. But we're picking up the new account. We'll give it a minute to come up. And then this will give me an account that I have full admin to deploy into, assuming, again, I didn't mess up anything. Now, to exec onto it. So you can see Spinnaker config. All this generates all the files. Actually, what I should confirm, you can see there's the simple kube config mounted and accessible. You will note you have the kubectl command line on here. As a matter of fact, you can even select which version of the kubectl command line you use. So if we do an export kube config equal simple kubectl get pods, you can see I'm able to run it from within the Cloud Driver. And this is exactly how Cloud Driver itself operates. It forks out to kubectl to do its operations. Once it starts, you could even do a PS and you could see all of its processes running. So let's do the logs and just see how it's doing. Hey, you can note here, it found simple, and it started a caching agent which loads data on that account. We have pods, it found some entries, it found some services. It is actually already finding data about that cluster. And it's happy within a few minutes. All right, let's switch back to our other share. All right, and I'm going to change this pipeline because we no longer have that account. Let's target that simple account, which is a completely different cluster. Now, one thing I could even do now, since I have a little more access, is I could target a completely different namespace. I don't have a namespace created. Let's override and say default instead of our spin workshop from the other where Spinnaker itself runs. And let's deploy into the default. And we're going to hit run. We click on it. Hey, you can see now we have a scaling replica set. You can even see the YAML that it is actually pushing out. And you will note certain things. Spinnaker will automatically add various labels and annotations to your app, including a managed by Spinnaker, so that it can track the resource. And hey, there we go. We have deployed a demo web app. You can see the state of it. Yeah, go ahead.
You have a hand raised.
Oh, thank you. Was there a question? Okay, the question on the download Spinnaker configs. Yeah, we pushed out a doc on the installation here. And this is a very simple download Spinnaker config script. This script doesn't create everything, and that's intentional because you don't have to have a service account, security context, any of this stuff. This is really tied to how you want to manage your Spinnaker. In a lot of these cases, you don't need a service account because Spinnaker is not going to communicate or work with the local environment. So this script does a very bare bones migration that emulates on a fairly limited basis on it. Meaning it's only pulling the deployments, the services, stateful sets, etc., not everything else you may have tweaked or adjusted. The Kustomize implementation here has a lot more capabilities and example components. And this, if we get into, so like the service account, it creates a service account for Cloud Driver, but it may not be needed for your installation use case. Just like it creates a service, you do need the service, but your cluster role binding may not be needed unless you were using this for internal cluster deployments type stuff. So again, this is the Kustomize does everything. The migration script tries to translate the very basics on it and needs to be adjusted. Where did I get? Depending on if you've done anything additional on top of it. So, simple example, this only pulls opt Spinnaker config. If you override the home Spinnaker folder for whatever reason to do an SSH key, that won't pull this down. So keep that in mind. It's a very basic script to do the translation, but if you've tweaked the installation or you want to add those features like the ability to customize the These cluster rule bindings, you'll have to add that extra on top of the script. The other thing is it does keep, you'll note in here, the deployment in here is named Cloud Driver. The script does still keep the spin dash prefix on that, if I remember right. Yeah, I think this will create, based upon the previous, all of the spin dash entries for the deployments, which is what Halyard was doing. So this is an example from scratch. If you have an existing installation, it's not going to entirely match because people tend to tweak and adjust things as needed. Security context, again, won't be needed in many cases, but it's there in case different companies need to. It's a very opinionated, clean start with all the possible configurations that you might need. Yeah, it's Kubernetes. These are really Kubernetes basic services that have been deployed. And that's what it does. You can see here, there's my 3 replicas running, deployed. You can even click on this particular pod, and see the handy dandy output deployed into that environment. Events, you will note the history. This will be a real-time operation of that deployment. So we have 7 minutes left on the workshop. Any other questions? I'm happy to go through other configuration options. I said I'm going to push this whole workshop repo with these config examples up. We can talk about triggers. We can talk about some other options here. What should we talk? The last thing I'll show you, as I said, microcates. It's not hard to install. You can use K3S if you want to target it. Do keep in mind, because you're running from one environment to another, you have to consider the networking, the RBAC, whatever. Spinnaker just forks out to kubectl, so it's whatever that kubectl can connect to. So if you're troubleshooting, that's a very simple thing to try, is exec onto it, run your kubectl commands to make sure that they run right. Other thing I will call out, applications. Spinnaker will automatically generate applications for discovered resources, i.e., it found the traffic running in that environment. There's different configs to shut off this behavior. But you'll note, hey, there it found traffic and was able to query the logs. You can then configure this app that it discovered in those different namespaces. Each one of these is a namespace as needed. Okay, so there's the installation, brand new. We've deployed our app. It's running happily. I can even delete it right here if I want it. Now you will note they even warn you, hey, it's controlled by a deployment. So I probably need to go to the deployment, not the replica set, if I want to delete it. And we're going to give it a 1-second grace period. This is an orchestration task. So we'll go over the tasks view. You can see, oh, yep, there's the delete manifest, which is, again, it's a micro pipeline that finished it. By the way, saving a pipeline is also a task. So every save, you can see the exact execution history of what it did. And there we are. I did it in an hour or less. I'll take the last few minutes to call out a couple of things from our documentation. When you do the install, as I said, you can target a lot of different ones. AWS, Kubernetes, Cloud Foundry, Docker, registry for images. This is more how you can reference and trigger. And again, I did a very simple example of my GHCR repo up here. You will note I do an encrypted reference as an example. You can store secrets that are used in the configuration, but not within pipelines. This is only for configuring things like a container registry. Hey, go load from a bucket and a pat token. I think that might need to be adjusted. This is, I think, the Kubernetes secret format with the N and the K, but no, that might be the bucket, and this is the bucket entry. Um, each thing you need to connect to has different config because every single cloud provider and every single GitHub connector has slightly different behavior on how you connect to it. You connect to Google, it's a JWT type service account. If you're connecting to Azure, it's a completely different set of credentials for there. Everything is just, unfortunately, a little different. When you're not talking cloud providers, but say artifacts, i.e. you want to do a clone operation, each one of the different systems has a different credentials. If you're talking a Git repo, one thing I'm going to call out, and this trips up a lot of people, a Git repo is a full clone of the repository of all of its contents. This generates a file that is used only by Kustomize Helm bake operations. But that's because it pulls down the entire repo and handles the artifact as a TGZ for baking purposes. A Git file is a single file, i.e. this uses a given API to do an operation against, say, GitHub. So do keep in mind that little nuance. Git repo is the entire contents. GitHub, GitLab, Bitbucket are a specific file within those. So config should all be documented. Each one of these is unique. If you want to pull an HTTP artifact, you can do that. You want to load an S3 artifact from a bucket, you can do this. GCS, so forth. There's a lot of configuration. There's a lot of options. And I haven't even begun to go into some of those. That might be a future workshop if there's enough interest. Okay, we've got 1 minute. Any last questions? I can stay on another minute, but happy to answer any others if there's any other questions. Going once. Going twice. If not, I will get this repo then pushed up here later. Thank you all for attending.